All right, we are now down to our last subtopic. We have the role of 5G run in smart and connected environments. Okay, I'm not going to discuss much about run, 5G run, or the telecom side because that's not my field actually. My field is more on the smart systems. That's why I established in the first subtopic that um, in order for us to have successful and effective intelligent electronic systems, we have to have smart infrastructures or especially for the connectivity purposes. And I already mentioned that 5G is now considered the um, fastest or the best option when it comes to data rates and one of the best options when it comes to range. Okay, so that's why we are giving some emphasis on this. Why 5G? Why not other wireless communication technologies? Okay, because of what we've said earlier. Okay, and of course, you'll get to understand more why with the help of this last subtopic that we have. Right? So, in the first place, what is 5G? Or RAN? What is RAN? Okay, radio access network is basically a wireless interface between user devices and the mobile core. So RAN somewhat like enables us to uh, connect better to the internet. So I think that's the simplest way to define it, right? So technically we get to have a wireless interface between us between our device and the mobile core or the core units of our cellular network. Okay, and ARAN basically includes the 5G base stations itself, specifically the G Node B or GNB uh, standards or technologies. Okay, so 5G base stations, and each station actually has MIMO antennas, not just MIMO, massive MIMO antennas. MIMO stands for multiple input, multiple output antennas. So when we say massive, then they can accommodate more. Okay? More inputs, more outputs. And we are going to see more of that later. Okay, so in the base stations, we also have RRUs or the remote radio units. And connected to the base stations are the DU and the DUs and the CUs, distributed units and centralized units for baseband processing. And of course, connected to the 5G stations are the backhaul and the front haul connections to the core network. Okay, to understand more of it, imagine um, this architecture or basic illustration. So when we say run, this is the coverage, the user part, okay, which could be our IoT devices, our mobile devices, and the station, the G-Node B station, 5G station. Okay, RAN is not much concerned on the UPFs or user plane functions. Okay, so um, our focus is on this part, and this one is more on the telco side already. Okay, and of course the network side. Okay, so RAN itself has evolved, although this is relatively a new technology. It has actually evolved already. So previously we have the traditional RAN, or originally we have this proprietary hardware for the remote unit or RU, and then the BBU or the baseband unit, which could be a DU or a CU. Okay? And the interface also is proprietary. So everything is proprietary, and therefore there can be compatibility issues if we if we try to mix different brands, different protocols, different um, technologies. Okay, and the good thing right now, because of the concept of SDR and SDN, we can now make use of the VRAN, or we now have the virtualized version of RAN. Wherein, for example, if we have this proprietary hardware and proprietary interface, we can now have an open hardware. So meaning the the exclusivity has been reduced. Okay, so somewhat open. It's already somewhat open in the BBU side. Okay, but not yet in the RU side. Okay, that's why when we say open run, so everything's open now. So we have an open hardware, an open interface, and an open hardware also. Open hardware in the remote unit, open hardware in the baseband unit. Okay, of course we have the open interface, right? And that's a brief overview of RAN. And let's see um, here, okay, a little bit of the G Node B architecture. Okay, so I'll just go in. I'm not an expert into this, so I'm just going to introduce the components of the GNB or G Node B architecture. So that's what we normally use in the 5G networks. Okay, so part of the GNB network is the RU, or the remote unit, and then before going to the 5G core, it will go through um, our BBUs, baseband units. We have the DU, distributed unit, and then the CU, the core, the centralized unit. Okay, so in between the RU and the DU is the front hall. Front hall. In between the DUs and the CUs is the mid hall, and the back hall connection is 5G. So sorry. Um, the the back hall is the interface between the CU and the 5G core. Okay, so front hall, mid hall, and back hall can be wired or wireless technologies. So wired technologies, the best option that we have right now is the fiber optics. Okay, so fiber optics cabling is normally used in these connectivities. But there are some areas that 5G, or that fiber cables are not feasible to be implemented. So that's why wireless point-to-point or terrestrial microwave is applied instead. Okay, or sometimes it could be satellite units, but that's in the rare cases, right? And with the help of technologies like massive MIMO and beamforming, we can now have more, um, or we can have better performance with these systems, with these networks. Okay, for example, massive MIMO is somewhat like this. Imagine the remember the analogy between frequency and the highway, or the spectrum and the highway. Remember the imagine the entire highway is the spectrum for our wireless communication, and then the highway lanes are the frequency channels that we use whenever we transmit something, whenever we communicate. Okay, so MIMO itself could have um, one by one, two by two, three by three, four by four channels. But when we say massive MIMO, it's already eight by eight. So eight inputs, eight outputs. Um, or if you look at its internal component, you'll see 8 by 8 array grid. Okay, so 8 by 8, 64 times something. Um, it means it can accommodate more inputs and outputs. So that's uh, the bottom line. Okay, And also, massive MIMO antennas are now integrated with beamforming technologies. So this is what I mentioned earlier. For example, if the antenna has perceived that there is a device trying to communicate with it, then it will focus its radiation beam towards that device. Okay, so it will minimize these other beams and maximize that one. Okay, so it can do the same thing in whenever um, with other users that that simultaneously communicate with the antennas as well. Okay, so at least it can um, optimize its performance. Okay, maximize the signal towards the actual users. Okay, and minimize, of course, the waste. Now imagine there are some radiations that actually we don't need. Okay, so with the help of beamforming technologies, we can get rid of unwanted radiations. Right. So we have some more other no other what do you call this details about 5G RAN. Of course, this is not my forte. This is not my field. I'm just going to show you some important concepts. Okay, so um, hmm, what else? So here's a comparison between a 5G and a 4G um, network. So this is 5G and this is 4G. So as you can see, the 5G can accommodate more and can perform faster connectivity, or can provide faster connectivity, right? Because of these what we call micro antennas or micro stations. Okay, so it will provide connectivity to each micro station so that each micro station can connect better to the devices that are within their coverage areas. Okay, so that is actually being done also by 4G, but the problem is it doesn't have um, features like massive MIMO and beamforming. Thus, the connectivity is less compared to the 5G. Okay, and another way to look at it is okay through this part, okay, what we call as network slicing. So with the help of SDN, we can slice for example, this is one channel. Okay, so we can actually slice this. Okay, this is for example, one slice is for UHD applications, one slice is for the phone communications, one slice for the massive IoT, and one slice for different mission critical IoT systems like emergency vehicles and um, stations like fire stations, police stations, medical facilities. Okay, so network slicing, we can do that with the help of 5G RAN as well. And most importantly, sorry, in my this is my concern. This is the bottom line for in my case, right? With the help of 5G RAN, we can now have MEC or the multi-access edge computing. Okay, so remember we have layers: cloud, fog, and edge. All right. So edge computing is at the bottom, fog is in the middle. Right. With the help of 5G RAN, we can now have we can now connect different edge devices. So that means they can connect here through fog computing instead of cloud computing. So the pricing is not somewhere in the middle. Okay, so sometimes the different edge devices have to be connected, especially if they are located within a city, within a metropolitan area. Um, Edge computing alone is not enough. Okay, so we have to level up to fog computing. Okay, so especially if, or even if it's not really fog computing, it's just managing different edge devices. Okay, so whether that's the case, or you want to proceed to fog computing, then using the core network of our 5G RAN, we can do that. Okay, so through network virtualization and network slicing, a single physical 5G network can be divided into multiple logical networks, ensuring appropriate bandwidth, latency, and security for the application of each slice. I forgot to mention why do we do network slicing. And now, in addition, multiple access edge computing or MEC unlocks a wide range of advanced applications and services that require high bandwidth and ultra low latency. High bandwidth because uh, they don't need to get congested in a few slots only. But Open RAN provides a bigger highway for all the different devices to communicate wirelessly simultaneously. Okay, so with the help of Open RAN 5G, we can do MEC, and that's my concern actually in my field. All right. So in addition, we have some emerging trends, or some of these are already taking place and commonly uh, available or being used already. So we have the Open RAN, AI-driven RAN, satellite integration, and the massive IoT and 6G integration. Okay, so in Open RAN, the RAN components from different vendors can interoperate. So like what I mentioned earlier, um, there's uh, we are no longer limited. We are no longer restricted to choose our BBUs and RUs. Okay, and also in Open RAN or ORAN, we can now reduce the cost and avoid vendor lock-in, and we can now encourage innovation through open standards. In other words, we can do a lot more. Okay, but nowadays, AI becomes more and more advanced and usable and common, accessible to almost everyone. Okay, remember that by applying AI in RAN, AI optimizes power levels, spectrum allocation, and beamforming, like what we mentioned also earlier. And with the help of AI, we can have self-healing RAN that detects and repairs faults autonomously. Okay, well, of course, with the help of AI, we can improve network energy efficiency. Okay, also, we might need to integrate our RAN to satellite. So 5 RAN plus low Earth orbit or LEO satellites can provide global coverage, because RANs, remember, cellular networks are um, not that common in oceans. So how do we connect the different continents or the areas connect the separated by oceans? Okay, so currently we do is satellite. What we do is by using fiber optics, transatlantic. That's the term I was trying to remember. By using transatlantic fiber optic cables, so we can now connect. places separated by oceans. But what if something goes wrong? Like um, uh, a line has been cut off, or what if for some reasons the fiber links are not usable? So um, we need a sort of emergency alternative. Okay, so satellite can help us, especially knowing that it can provide global coverage. Okay, so like what I am saying, it is critical for remote areas, marital communications, and disaster relief. Just imagine there's no 5G network in the ocean or 5G base stations. So how do seafarers and marine people, the Navy, get to communicate? So with the help of satellites. And when we are in remote areas, whenever there's a disaster, and we have to provide communication links there, so we can have satellite integration. And with the help of SDR and SDN, we can have our instant infrastructure, uh, okay, and connectivity with the help of satellite integration. Now, when it comes to IoT and 6G integration, so RAN will evolve into smarter, ultra energy efficient systems. And that's what we need actually. That's what's somewhat missing in our current IoT systems. We want them to be more energy efficient while making them smarter. Okay. Also, with the help of 6G, we are expecting that we can now add holographic communication, real-time digital twins, and tactile internet. Okay, so 5G and then 6G. We're actually going to the 6G, and I believe some countries like China are already on the verge of uh, of getting into 6G. I'm not sure lang. Maybe they're uh, we're not yet aware. Okay. And finally, if you weren't able to catch up any of the things that I said, or if you want a more detailed, a more informative explanation, a better way to explain these things, I highly suggest you go to the terahertz page, wherein one of their main topics is their RAN, radio access network, and they actually have their RAN academy. So you can visit their website, okay, or their FB page to learn more about this. Okay, this is their forte. Okay, and that would be all. So thank you very much. For our last quiz and evaluation form, kindly scan the QR code, and or you can type in the link or this URL to your URL box. Okay, and while doing so, you can watch these videos. We'll have our closing in a while. So thank you very much, everyone. We are so grateful for everyone, especially to those who stayed until at this point. So I really hope you have learned a lot, and we'll be glad to see you soon in our next offerings, next events. Okay. Again, my name is Marvin, and this is Akuni Projects. God bless.